Looking at section 5.5, part 2, we're going to use factoring to separate different functions. They tell us to solve the equation sine x tan x is equal to sine x, where x falls between 0 and up to 2 pi. So given an equation, we're allowed to work on both sides of the equal sign. The goal would be to get everything to one side of the equal sign and then look for factoring. So we're going to take that sine of x and move that over first by subtracting a sine of x to both sides. That's going to leave us with a sine x tan x minus a sine x is equal to 0. Now, since we're factoring, we're going to look for that common factor. They both have a sine of x, so we're going to factor that out. So sine x is going to multiply with a tan x to have given us that sine x tan x. And then we have a minus. If I take the sine x out, I'm left with a 1, and that's going to equal 0. Now going back to algebra 1 and using the zero product property, that tells us if we are multiplying two pieces together and it's equal to 0, set each piece equal to 0. That means we're going to say that sine of x is equal to 0. We're also going to say tangent of x minus 1 is equal to 0. And now we have to figure out what x is equal to. Now if we have a sine of x is equal to 0, what angle would give us a 0 when we take the sine of it? Meaning, go to your unit circle, look for your y values, where you're going to find 0 as a y value. That's going to be located at x is equal to 0 and x is equal to pi. On the other piece, we have tan x minus 1 is equal to 0. That means we need to solve for tan x, which means we're going to add the 1 over, which means tan x is going to equal 1. Well, the tangent of what value of x is going to give you 1. So you're looking for something divided by itself. That's going to be located at an x value of a pi over 4, well, the angle. But we'd have a pi over 4 or a 5 pi over 4. Because the negative divided by the negative would give you that positive. That's why we need to go all the way to that third quadrant. So what are our solutions between 0 up to, not including 2 pi? We're going to have 0. We're going to have 0. We're going to have next least would be pi over 4. Then we would have pi. And then we'd have our 5 pi over 4. So those would be our 4 possible solutions to this equation. Let's try another. This says to use an identity to solve a trigonometric equation. So they give us a cosine of 2x plus sine x is equal to 0. And again, x is between 0 and up to, not including 2 pi. So we have a cosine 2x plus sine x is equal to 0. Now there's nothing in common to factor out, but we have this cosine of 2x, which means that I can take it to my formula sheet and find out the formula for our double angle. So if you were to go to your double angle formulas, you're going to find the one that would make the most sense. We already have a sine x involved, so let's go ahead and use the one that says 1 minus 2 sine squared of xn. So that piece is going to make a 1 minus 2 sine squared of x, and then we still have this plus sine x is equal to 0. Now, looking at this type of a problem, I have a sine squared going on. And I'm going to take this and I'm going to rewrite it. But I'm actually going to rewrite it where I factor out or I divide all these pieces by a negative, because this x squared right here has a negative in terms of that leading coefficient. So if I take everything and I divide by a negative 1, I can rewrite this as a positive 2 sine squared x. And then I'm going to have, instead of a plus sine of x, I'm going to have a minus sine x. And then I have this 1 in the end, but if I divide that by that negative 1, we're going to have a minus 1. And what this is going to allow me to do is I'm going to rewrite this, and it's going to look a little bit nicer. This is the same thing as something like a 2 times something squared minus that something minus 1 is equal to 0. And if we take it kind of old school algebra 1 and just some nice easy factoring, you might be able to see that relationship between those three terms a little better. So if we were to factor down that basic trinomial, we'd have a 2x multiplies by x. The only way to get the 1 is a 1 and a 1. We'd have to have a minus 1 in the end, so we need opposite signs that in the end combine to that negative 1 in the middle. So we're going to need this to be a minus 2x and a positive 1x, that when I FOIL out my inside-outside terms, I have a minus 2x and a plus 1x to get that minus x. So now if I take it back to the idea of a trinomial, I can make sense of, I have a 2x as my first piece. So that means we're going to have a 2 sine x as our first piece that we then added 1 with. So I'm going to have a plus 1. And then my second binomial, I just had this x, which means I'm going to have just a sign x. And then we have a minus 1. And all I did was I took that trigonometric trinomial and I broke it down into the two binomial factors. And now I can use my zero product property. That means each of these pieces is going to equal 0. So I have a 2 sine x plus 1 is going to equal 0. And I have a sine x minus 1 is equal to 0. And we're going to solve to get x all by itself, or at least sine of x all by itself. So I'm going to have to, first one, I'm going to have to subtract 1 and then divide by the 2. So that means sine of x is going to equal the subtract 1 divided by 2. We need a negative 1/2. And then our other piece, we're just going to add the 1. So that means we're going to have sine of x is equal to positive 1. So now going to our unit circle, we have to identify, well, what is this x going to equal? So the sign of what value, or the y value, where do we see a negative 1/2 for our y value on our unit circle? Well, we're going to see that at a 7 pi over 6, and we're going to see that at an 11 pi over 6. Where would I have sine of what angle is equal to 1? Well, where would we have a y value of 1? That would only be located at a pi over 2. Right, that's the only place we'd see a positive 1. So that means what are our solutions for this? The solutions are going to end up being, we have the least number is pi over 2, followed by our 7 pi over 6, followed by our 11 pi over 6. And just a little note to self, if it cannot be factored, you might have to use your quadratic formula. Your opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. As I said, a little old school algebra coming back out. So the last little piece, if that wasn't hard enough, this might be a little bit easier because you get to take it to a calculator. These ones say to solve the equation, correct to 4 decimal places. So we want 4 decimal places for 0 is less than or equal to x, which is less than 2 pi. So they tell us that the tangent of x is equal to 3.1044. And a little side note, make sure that you are in radian mode on your calculator. Otherwise, you're not going to get the right answer. So if we had the tangent of x is equal to that 3.1044, in order to get x all by itself, that means we need to take that tan negative 1, that inverse tangent of the 3.1044. So if your calculator is in radians, go ahead and type in that inverse tan of 3.1044. Your calculator, rounded to 4 decimal places, should give you a 1.2592. Now, they mentioned that tangent of x is positive in quadrants 1 and 3. So if x is equal to 1.2592, well, in quadrant 1, it's going to be 1.2592. But if I need to get to quadrant 3, that means I need to add pi to quadrant 1 to get to quadrant 3. I need to get half of a circle ways around. So that means we're going to end up taking that 1.2592, and then we need to add pi, or we need to add 3.14159, so 16, I guess you want to call it. Approximately, we're going to end up with a 4.4008. So our two values are the 1.2592 and our 4.4008. All you have to do in your calculator is hit plus pi, and you get that as well. Let's try one more. This one says, what happens if we are taking the sine of x is equal to a negative 0.2315? Now, if you think about it, we are using that x had to fall between 0 and 2 pi. If the sine of x is a negative, when we take that inverse sign, we need to just use this as the positive value. So x is going to be the inverse sign of the positive 0.2315. And if you take and plug that into your calculator, you're going to end up with a 0.2336. So now if we're in quadrant 3, this was a quadrant 1. Quadrant 3 means we need to take this value, 0.2336, and we need to add pi to get to that third quadrant. That's going to give us approximately a 3.3752. And then in quadrant 4, this is going to be a little bit different. In quadrant 4, we can't really just add an increment of pi. What we're going to do this time is we're going to take 2 pi, that full circle, and then we're going to subtract the number that we have. And that's going to give us that x value. So if we take 2 pi, you can just throw that in your calculator, 2 pi minus that 0.2336, you're going to end up with x equaling approximately 6.0496. So because we went to quadrant 3, we just added pi to whatever that number was. When we were in quadrant 4, we took that 2 pi and we subtracted whatever that number was. So our 2 final answers for that are that 3.3752 and the 6.0496.